All right. Thank you all for joining. If you're seeing this, it means you're watching the live stream. So please ask any questions you might have as I go through our topic today. I'm going to walk through some quick slides and then show you all a demo. And at the end of the demo, I'll circle back to answer any of the questions that you've all had and hopefully make you all experts. So I'm excited to have you all here. Let us know where you're coming from, post it in the chat, and let's just jump into it. So without further ado, all right, so hello, I'm Franz Pear with Cyber Skyline, and today we're going to dive into revealing Python with Uncompyle. I'm going to show you how you can take a compiled Python file, a PYC file, and turn it back into source code so that you can analyze it for vulnerabilities. So let's start with a quick overview of what is Uncompyle. Very straightforward. Uncompyle is a Python decompiler. So for those of you who did not know, it's actually possible to compile a Python script, even though Python is a scripting language, meaning that it can be run directly from the source code. There is a way to compile a Python binary, which basically just takes your text, your plain text source code, and makes it into machine code so that it can run a little bit more efficiently. Now you can use Uncompyle to go backwards, go back the other way. So you could reobtain the source code from a compiled PYC file. Now, the reason why you'd want to do this, of course, is because the PYC files are they're the bytecode there, so they're not human readable. And using this Uncompyle program will let you go back, go from the left here, where we've got this gibberish binary. Maybe I should move my my body over here. All right, we've got this machine code over the bytecode on the left side, and then on the right side over here, this is where we've got our source code. That's a lot nicer to read, so we want to get that source code. Now, to get Uncompyle on your machine, it's really simple. If you've got a Unix or Linux-based operating system, you should have Python pre-installed. You should likely have pip installed already. If you do not, you can go and Google how to install pip very quickly. But pip is the most popular Python package manager, and Uncompyle is already within the pip repository. So you can use the single one-liner here to install Uncompyle. You're going to want Uncompyle 6 because that is the latest version of Uncompyle. So after you do that, you'll have Uncompyle installed on your machine, and this is how you'll use it. So at the very bottom here, I've got Uncompyle 6, and then you literally just pass in the file name, and that will just spit out the source code. It's really simple. So you can see in my example, I typed in Uncompyle 6. I've got my PYC file over there, and the response that I get back is this is the source code from the file. And you can actually see that Uncompyle will give us additional information, some extra metadata about the file, like what time it was compiled, as well as what version of Python it was using. So there's a lot of information that you get from Uncompyle, really quick and simple. Highly recommend this as a tool if you're going to be reverse engineering Python. Now, a quick heads up when you are using Uncompyle and when you are reverse engineering with Python in general, you need to make sure, absolutely need to make sure that you are using the correct version of Python. Because if you are not, you're going to likely get some errors. So this applies to whether you're running the PYC file or the PY file. So the compiled version or the source code, both of them, you need to make sure you're using the right version of Python. Now, depending on your operating system, when you type in Python, that might default to a different version of Python. So I believe the latest versions of Linux and Unix systems, they're going to have their Python command mapped to Python 3. Some of the older ones might have it mapped to Python 2. So if you just generically type in Python and the name of the program, it might not be compatible. So you can be explicit. You can specifically say Python 2 or Python 3 when you run the program. The demo I'm going to show you today, we're going to be using a file that has been compiled and running Python 2. And so on this left side here, where I try to run Python 3 with the Python file, you can see I get this syntax error. it indicates that there's something wrong with the way that the code is being interpreted. That is an issue where I'm using the wrong version of Python. On the right side here, I'm explicitly running Python 2 and running the program that way. I don't get a syntax error. It says incorrect, but that's just because I have the incorrect answer. The program, though, is actually running correctly. So keep this in mind. Make sure you're using the right version of Python, or you're going to see these syntax errors and maybe some additional funky stuff. I can't guarantee you that the same code, one set of code will work the same in Python 2 and Python 3. So if you have issues with one, try the other, and you can also verify on your PYC file what version of Python it was compiled for. All right, so let's go through a demo and break some Python. If you are watching us live, now is a great chance to ask any questions that you might have, and I'll circle back to them later in the episode. So I'm over here in my Kali VM, and I've already installed Python and pip, Python and Uncompyle. I've got everything installed here, and I'm actually going to go another step further and also zoom in for you all here, make this a little bit easier to see. Let's see if I can get my terminal size. All right, font size. Let's just make this a little bit bigger. Perfect. All right. So what I've done is I've gone through the practice gym on the Cyber Skyline platform, and there is a, in the enumeration exploitation category, there is a Python 3 question, and that one has a file that you can download and analyze. And what we're trying to do is find an input into the program that will result in a correct validation. So let's go ahead and do that. Over here, I've got the file that I've downloaded, and I've got Uncompyle. So I'm just going to simply run Uncompyle, P-Y-L-E, Uncompyle 6. I'm going to run it on the PYC file. When I hit enter here, you'll see that it prints the source code of that PYC file. Now, I want to save this so I don't have to try to interact with it directly within the output of my terminal. I'm going to save this to just call it python.py file. And then when I do this, I can open my python.py file, and you can see here, this is all the source code. So at this point, this is when we want to actually start our analysis of the code. It's not a very long file. It's only 30 lines, and a third of this is comments already. So it's not too difficult. And just stepping through this, we'll start at the very top here. Import sys, this is the system module. And then we've got a function main. So this is likely going to be the main function that gets called when the program is started. And then we can see this if statement is checking for the length of sys.argv. Argv, those are the command line arguments that are being executed when this program is being run. And so this is an array, and by default, your argv, the first element in the argv is going to be the Python program that you're running, and the second one is going to be any subsequent, is going to be the next thing that you actually type in. And so it looks like we're checking to make sure that there are two arguments. There's going to be, the first one is going to be the name of the program, and the second one is going to be whatever we type in. And if not, it's going to print invalid args. It's going to return. So it exits basically. And then it is creating a variable called password, which is set to argv1. So arrays are 0 indexed. So that means argv0 is the name of the program, and argv1 is going to be our password. And then we create another variable here called builder, and it's set to 0. So this is a number here. And then we've got a for loop, for C in password. So this is for each character in the password. We are going to add to our builder the ord of C. So this is the ordinal. And if you are not familiar with this, just give it a quick Google search, Python ord. This is an integer representing the Unicode character. So basically this is going to return the ASCII value of that byte. So then our builder is basically going to be the sum of all of the character codes within our password. And then after that, it looks like we're doing a byte shift. We're shifting left 2, and then we're executing, I don't know what this tilde command is, and then this is an XOR over here, and then we've got another tilde. I can definitely go online and just confirm what these different operations are, but what we could do is just play with the Python command line and see ourselves what the result is. And then we've got this final if statement here. If builder equals this specific number and the ord of password 0 is 78 and the length is 11, then print correct. Else print incorrect. So let's actually try to run this. We know that this is going to take two arguments. The first one is going to be the name of the program. And the second one is going to be the password that we want to validate. Now I'm going to show you why it's important to have the right version of Python. I know that this program says python3.pyc. That's just a file name. It doesn't mean it's actually Python 3. This just happened to be the third Python related question we had in the practice, which is why it's called Python 3. But that doesn't mean it's a Python 3 file. If I try to run it with Python 3, it's going to give me an error. And then if I try to run the source code, the python.py file, that's where we get the syntax error over here. So keep in mind that you have to use the right version of Python and don't get deceived by the file name over here. So we want to specifically run Python 2. And if I run Python 2 on our py file here, it says invalid args because I didn't provide in a password. So let me just type in some gibberish. And it doesn't say invalid args anymore. It's saying incorrect. So we've made some progress here. We are now further into our program. So instead of exiting on line 11, we are now making it all the way to line 22. That's the if statement. And this is where we want to validate our command. And so if we validate this correctly, it should print correct. And if it's incorrect, it's going to print incorrect. So now we need to figure out what password do we need to pass in that will make this if statement correct. Now there's some easy things right off the bat. There's 3 conditions. We're checking for builder equals this number. That's not the easy one. The next 2 are easy. This one, ord of password 0, this is just checking for the character code of the first letter in the first character in our password. So what we could do is just look up character code 78, and that will tell us what the first character should be in our password. And then we've got another condition checking for the length of the password equaling 11. All right, so we know our password has to be 11 characters long, and we know that 78 is the character code of the first character in our password. So if I go and I look up an ASCII table, I'll zoom in a little bit here. So we are looking for character code 78. So character code 78, this looks like an N, uppercase N. All right, uppercase N, that's what we want. That's the first character. And there's a way that we can confirm this actually by just modifying the source code and telling us how we're doing along the way. So if we say if ord password 0 equals 78, print first are correct. So we're just modifying this very quickly, and we're just doing a sanity check here to make sure that we did indeed get the first correct character. So now I'm going to go run the program again, and let's just test it out for some gibberish again. This should just print out incorrect like we were expecting. But if I go back and I make the first character an uppercase N, I would expect that we should have that print that we just added in there get executed. And you can see here it says first character correct. So we're matching one of the three conditions now. Okay, now the other condition that was easy to meet is this length of the password equals 11. So let's give ourselves another sanity check over here. And let's just say if if len password equals 11, print length correct. All right, so now we're going to try to make sure we get the length correct. So I typed in an N. I'm just going to type in 10 A's. That should give us the 11 characters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oop. We did something wrong. What did we do wrong? I made a typo. That's what we did wrong. This is why we got to do sanity checks, just in case we make any mistakes. So let's run this again. And now we get length correct. So we are matching 2 of the 3 conditions now. The last one is going to be the hardest condition to meet. So we need builder to equal this number. What I'm going to do is I'm going to start with this number and go backwards and hopefully get to what the value builder is after we type in the password. Because all of these other commands here, this bit shifting that's happening and all these other operators, that is not input that we control. That's not something that we can change in other words. And so this we can ignore. What we care about is what the state of builder is after we type in our password, because we can control the password, but we cannot control what happens here. Keep in mind the program, the prompt was asking us for what is the password that will validate correctly. We've got to make sure that the password that we are typing in validates against the original program, not against any modifications that we make to this program. So we can't assume that we can make any changes to these lines. We have to keep those lines in there. And all we can do is modify the password because we're in control of the password. Okay, so now we know that this is an important number. So I am going to just copy this and create another file, another Python file, and try to go backwards and get the value of the builder immediately after it generates builder from the password, such that after all these operations on lines 18, 19, 20, 21, it equals this value. So let's do a new file. I'm going to call it test.py, and then I'm going to paste in my value. So I'm going to say builder equals, and I'll just paste that right in there. And then I am just going to go backwards on these commands. So going to copy and paste this. We're just going to do it in reverse order. Paste, copy, paste, copy, paste. Okay, now this one's tricky because we're going to have to go the other way. I think. I'm doing this live, so we have to see how this is going to work for us. The bit shifting destroys data. So let's just give this a shot and see what we get when we do this. So if I run Python on our test, this is the number that we get. Now, the question becomes, how do we have 11 characters that sum up and equal that value? Now, the way that I would approach this is I would just take the first character that we know we need, that is this 78, and just subtract it from this number. So if I go and edit this here, and then I do builder minus equals 78, that leaves us with 10 characters that now all need to add up to whatever the remainder is. All right, so we're getting closer here. Now I'm gonna just double check some notes here because I'm a little bit worried about that bit shifting, because bit shifting does destroy data, so you might not be able to go the other way as easily. You need to be able to verify that that the data is being preserved. So we undo this command, then we undo this command, we undo this command. Oh wait, yeah, no, that's correct. I think I'm going in the incorrect direction on my shifting. Okay, yeah, so the shifting in the original code is shift left. We actually need to reverse that. We need to shift right. All right, let's shift right. All right, we're getting a much different value now. So we're getting a value of 620. All right, this makes a little bit more sense to me now. So we have 620. This is the value that our characters of the password have to add up to, with the exception of the first character. So we have 10 characters remaining, which means if we just divide this by 10, that's 62. So if I just go to my ASCII table here and I look for 62, I can see that this is the greater than sign. So if I have as my password the uppercase N, which maps to this 78 value, and then the 10 characters that I have afterwards are all the greater than sign, what that should do is it should add up to the correct value, so that after we execute all of these commands over here, the final value of builder will be this number over here. So let's go and give that a shot. So I'm just going to run the program, python.py, uppercase N, and then 10 greater than signs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I hit enter, if I hit enter, you can see that I need to put this in quotes because these are special characters. All right, I hit enter. We pass our first sanity check. We pass our second sanity check, and then we get the final correct at the very bottom of the program here. And as another confirmation that we have this correct, instead of running this on instead of validating the password on our source code, I'm going to validate the password on the original PYC file. So I'm going to type in Python2, and then the original PYC file, and then 1N followed by 10 greater than signs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I know I'm a little bit in the way here. So there's my 10 greater than signs. And then I hit enter, and we have correct again. And if I go back to our challenge in the practice, and I just type in the N, myself over here, type in the N with 10 greater than signs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I hit enter, and we have that challenge correct. So we've successfully decompiled a Python PYC file and managed to analyze that code and find a way to validate against the program. That was very, very quick and easy solution. I'm sure there's going to be a lot more complicated Python programs. And if the Python program that you are trying to reverse engineer has some sort of obfuscation, maybe someone ran it through an explicit obfuscator so that when you decompile it, it's still a bunch of mess. You will likely need to do some additional effort in terms of running it through some sort of like code beautifier, or actually just like manually writing notes for yourself and saying, hey, this is what these 3 lines are doing, and this is what these 3 lines are doing, and trying to piece things together. Because as it was the case here, when we ran the Uncompyle program, it gave us very, very nice looking source code. I'm pretty sure it was probably 1-to-1 with the original source code, and there wasn't any sort of hoops we had to jump through to solve that problem. But I'm sure in the future you might experience some PYC files that have had some additional obfuscation done to prevent reverse engineering, and it'll be a little bit more work to take the source code, quote unquote, and understand what it's actually doing. So I hope you found that valuable, and good luck with the rest of your practice. Now, if you're joining us on the live stream, now is a great time to ask your questions. I'm going to go through them and see if I can help you all become better experts. So let's see here. We've got, I guess this isn't really a question, this is a comment from someone in the chat. The tilde is the byte inverse operator, also called a not. So that's a pro tip for anyone who is watching and was not unsure of what that is. Oh, bit operator, not byte operator. Martin is asking from YouTube, how do you know if a Python file is a Python 2 versus a Python 3? I believe the Uncompyle program, and we can run this again, it will attempt to figure it out and try to tell you. It's not going to be correct all the time. You can probably run some other tools that might be able to tell you. In this case, I think it gets it wrong, because Uncompyle says decompiled from Python 3.9.12, and when we tried to run it with Python 3, it didn't work, and when we ran it with Python 2, it did work. So the end-all be-all test on whether it's this Python 2 or Python 3 is when you run it with Python 2, does it work with Python 2? And when you run it with Python 3, does it run with Python 3? If it runs with both Python 2 and Python 3, then I guess it didn't matter and you're good to go anyway. So yeah, that's kind of like the end-all be-all test. All right, we've got another question. Do you know of any other tools for decompiling other languages? There are a ton of decompilers. If you go on Google, you can probably search for some GitHub repositories, which just have lists of different decompilers. People have got different blogs on decompiling. I know there are decompilers for Java. There are decompilers for like C programs even. I know Ghidra, the reverse engineering tool, has an automatic decompile back into C source code functionality. It doesn't work perfectly, but it can sometimes do a pretty good job. There are a lot of different tools out there. I would recommend going and trying to find a more comprehensive list than what I can just rattle off the top of my head. David is asking, when decompiling, is data lost in the source code, normal for larger files such as comments? Yes, that is very, very common. It is going to depend on the settings of it's going to depend on the settings when that program is compiled. So when you're compiling it, I don't know the specific settings with Python compilation specifically, but I know when you're compiling C binaries, for example, there are options to specifically remove the comments. There are specific options for making some additional optimizations to the compiled version, and those optimizations necessitate changing some of the bytecode there and making it so that you can't get a one-to-one reversal into the source code when you try to decompile it. So a lot of it will happen just from natural wanting to optimize for efficiency and those settings in the compilation process, but then there's some other tools as well, which will explicitly try to obfuscate the code so that when you attempt to decompile, there's going to be data loss there, and it's not going to be one-to-one. Now, I will also say here, the caveat is there will be data loss in the sense that you won't be able to go back to the original source code perfectly. The functionality is going to be the same, assuming you're using a correct decompiler. So in theory, when you decompile a program and you've got the original compiled version and you've got the source code, both should be functionally the same. They should both do the exact same thing. Now, does the decompiled version match the source code? The answer is going to be most likely not. Most likely there's going to be some sort of data loss there in converting back and forth with the source code and the decompiled version. All right. Well, that looks like all of the comments in the chat. I hope you all found that to be very informative. If you've got any other lingering questions, we're going to upload this video back onto YouTube after we are done with editing, so you can ask some additional questions there. We go in once in a while and check up on those questions. And if you've got any suggestions for other topics you'd like to learn about, leave them in the chat right now. We definitely use your comments to give us ideas for future episodes. But thanks once again for joining, and I hope you have a great rest of your day. Take care.